This is geotrig, lesson 14, day 3. The only thing we're going to talk about is this idea here, and we're going to complete more problems like yesterday. Some of them dealing with angles of elevation and angles of depression, and others that is just say solve the triangle. Okay, so here we go. The first one, guys, is if I am looking down the street, we would think that my line of my vision, if I did not move my head, would be going straight with the road. Okay, we're going to assume that if there was someone standing here, if they look straight across, it'd be parallel to the floor or to the ground. Yes, just straight across, straight out. If they were looking up at an airplane, their eyes or their head would be tilted upwards, and that angle that is formed with the ground or wherever the line of sight on the ground is, or from horizontal line, that angle going up to the line of sight of the object in the air is called the angle of elevation. It's when we are looking upward or up. Angle of depression means I'm looking down. Where does this come into play? You're in your treehouse back at home. And your friend shows up and says, hey, let down the ladder so I can get into the treehouse. And so when you look out your window, you have to look downward from your horizontal, which would be up in the air. You're looking at a downward angle. Yes, your friend is looking at an angle of elevation to see you. So these things are linked together, actually, guys. So if I'm riding or flying an airplane and I have to look at the ground, I have an angle of depression. If I'm the person on the ground looking at the plane, I have an angle of elevation. So they might say, guys, the pilot spotted an object on the ground with an angle of depression of 30 degrees. Which means you need to identify that I'm using the angle of depression, and that, let me clear this out, the angle then formed is 30 degrees from looking straight across to his line of sight, which is looking at the object, which is downward. Okay? So we need to know that. It's a quick 5-minute explanation, but everybody hopefully gets that. So how is this going to help us? It helps us when we start to solve problems. Guys, I'm going to solve this problem, which goes back to what we did yesterday, where I have to solve a triangle. So from here on out, I know that worksheet just said solve for a particular side or for a particular angle. If I just give you a right triangle, has to be right triangle. Trig only works only on right triangles. If I gave you a right triangle and I said solve it, you need to tell me everything about it. All the sides and all of the angles. Okay? Yes, you could technically use Pythagorean's theorem, a squared plus b squared equals c squared, to solve for remaining sides if you're missing one. Or you use trig. I say you need to default to trig. You can check it with Pythagorean's theorem. First problem. I need to solve that triangle. What am I actually going to solve for? What's missing? Angles at A and C. So if I'm going to solve for angles at A and C, I will kind of have to establish where am I going to be looking from. Okay? Yeah, I get to choose. You get to choose. What angle are we going to solve for first? Okay, we'll start with A. If I want to know angle A, that means, according to angle A, 8 is called the opposite. 6 is called the adjacent. 10 is the hypotenuse. Guys, I will write that down on my triangles, on my paper, on my worksheet. So therefore, I know what I'm doing. I know my sides. But remember, this only is good for what angle? A. Because as soon as I change the angle C, adjacent and hypotenuse switch. Yes? Okay. So, here's the really cool thing. I need to set up my trig functions. Wait a minute, I'm missing something if I'm going to use my trig functions. What is that? SOHCAHTOA. So I'm going to write it down. This is probably one of the few times, guys, that I will allow you to write a formula of some sort on your paper and say you get to use it for the whole entire paper or that page. If you guys in your homework turn the page, you should write that down again. The reason is because when we go to use parts of it, you have to write down the remaining formula every single time. Because remember, guys, I always want to see formulas every time you use it. So, here's the cool thing. If I'm looking for an angle, that kind of is in the place of the big S, the big C, and the big T. Yes? Because OH, AH, and OA stand for the sides that correspond with opposite, hypotenuse, and adjacent. You know all of those. So the only thing you don't know is an angle. That allows you to use any of the functions you want. So now, which function do you want to use? Sine, cosine, or tangent? Cosine. Let's use cosine. So, cosine of A, we don't know angle A, so I'll call it angle A. Cosine of angle A is equal to, let's not put the numbers in yet, but what is cosine?
Adjacent over hypotenuse.
There we go. Ca, adjacent over hypotenuse. Because we're talking about SOHCAHTOA. When you stub your toe, you got a SOHCAHTOA. Okay? Now, I can start to fill in everything. We don't know what angle A is, so it's still going to stay cosine of A. What's adjacent?
6.
What's hypotenuse?
8.
Oh,
Hypotenuse is 10. Hold up.
10. Okay? And here's the cool thing. Now I can start to solve for A. Now I can reduce that. I think you guys will be okay with that. So the cosine of A is equal to 3 over 5. Okay?
What's the point of reducing it?
There is no, okay. There is no point if you're just going to take your calculator out to reduce it, because 6 divided by 10 is the same thing as 3 divided by 5. Yes? Where reducing it is going to come in handy is that later on, I'm going to pull your calculator out from under you as well. There actually are certain ratios that you will automatically know sine, cosine, and tangent for.
You're saying we won't be able to use them on like
A certain test or quiz, correct.
that's fine.
It's going to be fine. Because eventually you will know the sine of 30, the sine of 45, the cosine of 45, the cosine of 60. You will also know the cosine of 30 and 60 and 45. You will know tangent of 30, tangent of 45, and tangent of 60. You will know all those, and you will also know the sine, cosine, and tangent of 90, 0, 180, 270, and 360. Those are all things you will know or have the ability to find very, very quickly. Okay? We're not there yet.
That's cool.
We're not there yet. Okay? That's a whole other lesson. So, here we go. We reduced it just to see if it's one of the ratios that eventually down the road I will know or you will know. But we don't. No, we need to get rid of cosine. So to get rid of cosine, we take the
Oh, the sine.
the inverse cosine. But what I do to
One side is do the other.
one side, I moved it over so I can fit this in here, I do to the other. Because the inverse cosine of cosine cancel each other out. It's like taking a square and a square root, right? Boom, gone. So you're left with A equals the inverse cosine of 3/5. Make sure you guys are in degrees on your calculator, and it will tell you an angle. Please do so. Everyone should be trying this. 53.13 degrees. I would round to at least 2 decimals. That'd be a good spot. Okay? That's just A. You now need to find C. Now there's a quick way. What's the quick way to find C?
Just add the 90 to the 50.13 and then.
Okay, we could add the 90 and then realize they all add up to 180. Or, since one of them is already 90, the other two have to add up to 90. So I could just take 90 minus the 53.13. I'll have my answer for C. That's a good check. I'm forcing you to use what? Trig. So guess what? To find C, do the exact same process we did here, but from the perspective of C.
Okay.
We're not going to complete that work because you guys should have done this last night in your homework. But now, if I'm looking at it from C's perspective, it's not adjacent anymore, it's opposite. It's not opposite, it's adjacent. Hypotenuse ends up still being hypotenuse. I don't want to use cosine this time. Let's use something else. Tangent, okay. Tangent of C is equal to what ratio? Don't give me numbers. Opposite over adjacent. Is everybody okay with that?
Yeah.
And then it becomes the exact same process. The tangent of C, which I don't know, is opposite 6 over 8. Or tangent of C is equal to 3/4. And then take what of both sides? Inverse tangent of both sides. Guys, you should do that, and you should end up with what? 36.87? Okay? I'm not going to finish that with you. Moving on to the next problem. I only give you 2 sides, but I tell you it's a right triangle. We have to use trig. Can I solve for the third side without using trig? Yes. But where are we going to? No. So, in this case, I need to find B or A the exact same way I found C and A from the last problem. But the problem is, according to which angle I have, I only have a certain ratio. So which angle do you want to solve for? Let's do A. Okay, so let's start at A. That means 5 is opposite, 15 is adjacent. Which trig function do I have to use then?
Tangent.
I have to use tangent. Do you see how that works?
Yep.
Now granted, if I came from the B's perspective, it would still be the same, opposite and adjacent, just switch their numbers. I'm not going to finish that problem either because then from there we could solve for the rest of the way. Okay? These are just kind of the review. That's what we did yesterday. That's what that whole worksheet was about. Is just keep doing problems using trig, setting up those ratios and solving for the unknowns. This is the type of problem, guys, that we might start seeing with that angle of elevation or depression. It says find the angle of elevation of the plane from point A on the ground. Essentially, you're finding what in the diagram? Not A, X. Because X is in the spot now where A should be, right? You can see that this is an angle of elevation because I'm going from the floor looking up to that airplane. Which trig function am I going to use? What's 300 compared to x? It's opposite. 400 is? So, which one's opposite and adjacent? So tangent. Tangent of x is equal to opposite of?
Adjacent. Is that 300 or 800?
There's 300 and 400. So tangent of x is equal to? 300 over 400. And I think if you reduce that, that's 3 over 4 again. That's like the last problem we did. So it all comes down to identifying what does it mean to be angle of elevation or depression, and then it just becomes a simple trig function. I'm hoping that these don't take very long once you get the idea. So you just have to take the inverse tangent, right? I'm not going to finish it. We'll just write this out. So x is equal to, and make sure you're in the right mode. I'm assuming that's less than 45 degrees. 36. I only know this because the inverse tangent of 1 is 45. So it should be about 36 degrees. Give or take, there's some decimals in there. Okay? Any questions on that? Now, this is again more of your elevation. It doesn't even give you a diagram. You need to draw your own. These are good problems. A man 6 foot tall is 200 feet from a tree. And he measures the angle of elevation to the top of that tree is 11 degrees. How tall is the tree? Guys, it wasn't until recently that we have lasers. And these lasers are able to tell us the distance between objects, or how tall something is. Back in the day, to do surveying, you had to use trig. If you want to know how tall a tree was, you can use trig to your advantage and figure out how tall it was, but just by looking at the angle of elevation that you took to look at it, and how far away you are. And that's what we're doing here. So draw yourself a picture. Now, we need to make some assumptions here. What's the assumptions?
He's 200 feet tall.
The tree is 200 feet tall. It's telling us that. We're not assuming that.
Oh my God.
But the ground is level?
Okay, the ground's level. That's something we have to figure out. So here's our ground, right? Here's my tree. Okay? Just don't worry about the levelness of this, okay? What else do I have to assume? The guy is standing and he's looking to that top of that tree, yes? But he is what?
6 feet tall.
He's 6 feet tall. Where is he looking from? 6 feet up. That's where we're going to have to make the assumption. Okay, if I'm 6 feet tall, are my eyes really 6 feet off the ground? No, there's a couple inches below, right? We're going to assume if you say someone's 5 feet tall, 6 feet tall, and they're looking at something, you need to take into consideration that your triangle is already starting, not 5, it's 6, right?
Yeah.
Your triangle is already starting 6 feet in the air. Can you guys picture that? Because the guy, if he looks straight across to the tree, that line of sight looking straight across is 5 or 6 feet above the ground. Then he starts looking up from there. At an angle of elevation of 11 degrees. How tall is the tree? Oh wait, he's also what? 200 feet away. According to angle 11, what sides do I have? Or in question here? because that's going to help us solve it. What's 200?
That's the
Adjacent. And h would be opposite. Which function again? Seems to be a lot when you're solving these types of problems. It's tangent again. So tangent of theta is equal to opposite over hypotenuse. We know we're talking about tangent of 11.
No, it's adjacent.
Oh, sorry, you're right. Just seeing if you guys are paying attention. It's good to know.
Yeah.
Adjacent. So, what's opposite? H over 200. How do I solve for h? These are the nice ones.
Times 200 on each side.
Just multiply both sides by 200. So h is equal to 200 times tangent of 11. Some of you guys will have to put tangent of 11 first, hit enter, then multiply by 200. How tall is this tree?
38.88.
38.68 feet.
No, 88.
89?
No.
8.
88 feet. No, it's not.
And then you have to add
Why
the
not?
6 feet.
Yes, we have to add the 6 feet, guys. Sure, your triangle has a height of 38.88. But then you have to add 6 more feet. So the actual height of the whole thing is 44.88 feet. That's where your angle of elevation problems are going to come into play. 6 talks about an airplane flying altitude of 3,000 feet. That means he has a what of 3,000 feet? A height. Spots an object on the ground with an angle of depression of 26 degrees.
You have to minus.
What is the slant range from the airplane to the object? What do you mean by slant range? There would be the hypotenuse of your triangle. Okay, guys. Here's my airplane. Flying in this direction. We know that he is off the ground 3,000 feet. Yes? It says he has an angle of depression. So that means we are probably looking up. No. Angle of depression means he's looking down to the ground with an angle of depression what? So where do I put that? Do I put that over here? Do I put that there? There? Or over here? Where's the angle of depression? Everybody hold their arm straight out. Now take your other arm and show me an angle of depression from your original arm.
There.
Like move your arms across.
That.
What's your angle? Where is the angle?
Right here.
It's in between it's in between your arms, right? Guys, I did that because some people are going to try putting 26 degrees right here. Is that true? No, 26 degrees is from the straight out looking going to down 26 degrees. It needs you to find x, your hypotenuse. This is going to catch students. If I left it right here, people are going to get this wrong. How do I find x? What sides am I given? First of all, is 26 even part of that triangle that's even formed right now, right here?
No.
No.
Isn't it?
Unless you know some things about it.
It's 90 minus 26.
It's 90 minus 26. That'll give you what?
Oh, the right angle.
Not the right angle, but this angle, right? We're assuming that the ground is at a 90-degree angle to the height. What does this become?
64.
64 degrees inside the triangle. you now have adjacent, you need
Oh,
hypotenuse. You guys see that this is adjacent? This is the hypotenuse. Which trig function will allow you to figure that out? So the cosine of theta is equal to adjacent over hypotenuse. Doesn't equal 90? Cosine of 64 then is 3,000 over x. Can you guys solve for x? I would hope so. Guys, your homework is going to be worksheet number 2 from lesson 14. I call this one the angle of elevation worksheet. Have a fantastic day.